Hello my friends. In this video I am going to teach you how you can write the schedule section of your data file. What is schedule section? Basically in the schedule sections we are defining our wells. For example, how if we have, for example, 5 injection wells and 5 production wells. So in this section we need to define those wells, their location, how their completion and their production scenarios or injection scenarios, as well as in this section we are telling the Eclipse that what will be our time steps and how long we want you to do the simulations. So schedule section is the main section that reservoir engineers are going to work and change the data file based on that. So as I told you, in this section we are going to define the well. For example, we are going to say that where will be our well locations, and we are going to tell the Eclipse that how will be our compilation, which layers we are going to do the preparation, and at the end we are going to tell how we are going to produce or inject from those wells. And then later we are going to tell the Eclipse that what will be the simulation time. Okay, so time step, simulation time that we want the Eclipse to do the simulation. We mainly use this schedule section for the history matching and prediction. So if you have some data, for example, let's say that you are doing the simulation for a reservoir that this reservoir is producing for 10 years. So you have a production data for 10 years. So you can change this section to do the history matching, or you can predict what will be the, for example, oil recovery factor in next 10 years or next 20 years. So first step is to define the well. For define a well, you need to use well specs keyword. So this well specs keyword is introducing a new well to your system, to your reservoir, and it's taking too many items, but the most items is the well name. So for each well that you define in your reservoir, you need to have a name for that well. For example, here in the data file for the well specs, we say, for example, the name of our first well is a production. So this is the name of well. The second item should be wells group name. So okay, what's the wells group name? Sometimes, for example, you have 5 injection wells and 5 production wells, and you are going to say, I am going to group all injection wells in one group and all production wells in another group. So let's say for I'm going to group all injection wells in the group that name is, for example, inject, and whole production wells in the group that its name is, for example, produce. Okay, so that is the name of the group. If you have a well group's name, for example, if you define those groups, you can write it here. Okay, but if you don't have any name or any group in your system, just leave it as a default. So you can write 1 star. It means that this item I'm going to leave as a default. The next item in the well specs will be I location of head. Okay, so it basically in the third and the fourth items you are telling the location of the wellhead. Okay, so where will be your well? For example, in this here, I am saying that in the grid number 1, which I is the number 1, and the grid which its J is 1, it means that grid number 1, I'm going to put my production well. Okay, so it will be 1, 1. But for injection well, I'm going to put injection well in the grid number 20 in the X direction and grid number 20 in the Y direction. So you are going to have 20, 20 here. The next item is a reference step for bottom hole pressure. Okay, so you need to define, for example, you need to tell the Eclipse that where will be the reference step to calculate the bottom hole pressure for all these, for the production and injection wells. Okay, So if you an idea about if you have a reference that you have its bottom hole pressure, you can put it here. But in case you don't have anything right now, just leave it as a default. Okay, so write one star here and move to the another item. The next important item is that preferred phase for the well. Okay, so you define the well. For example, here you have production well, here you have injection well. You need to tell the Eclipse that what is the main reason for defining this well. So here you said I'm going to produce oil. So write oil here. For the injection wells, you can say I'm going to inject water. So write water. The point is, sometimes, for example, here you define the production well, it is oil, but you can produce still gas from this well as well. So this is just a label, okay? And the label says that mainly I am going to produce oil from this production well, but still you can produce gas as well, water as well, or any fluid from this production. And if you go to the reference manual, you can see more items. But for now, the main items that you need to remember from the well specs is that you need to define the name, you need to define the location of the well, and you need to say that what is the preferred phase for this well. For example, here is oil and this one is water. And another important thing is that well specs for each well, for when you define each well, it needs to finish with a slash. Okay, so if you define production well should finish with a slash. If you define injection well should finish with a slash. And at the end, when all these wells are done, you need to have another slash to finish the well specs keyword. Okay, so till now we defined our wells. We defined two wells, production and injection wells, and we allocate the locations. The next step is to do the compilation. Okay, so right now you have a well, but you need to create a connectivity between well and zone. Okay, for that you need to use compat keyword. Okay, compat keyword is a like well specs keyword is taking too many items, but the most important items is a first item, which is a well name. So you already defined in the well specs section, you define the well and it's a production well. So in the compat section, you need to have the exact same name here. So because you are going to do the completion for the production well, so you need to have it here. And also you are going to do the completion for the injection well as well. So it should be exactly the same as this one as well. So it should be I. So right now you have injection, production, and injection wells. So this is the well name. The next step is the I and J location. Okay, I and J location of the wellhead. So you have I and J locations in well specs. So it should be exactly the same as here. So your production, I location for your production well is 1, and J location for your production well is 1 as well. And for injection well, I location is 20 and J location is 20 as well. So these three are exactly the same as well specs. The next item is saying that what will be the initial upper part of the connectivity between the zones. So it means that will be the upper layer that your well is going to connect. For example, in this case, this is the upper layer that my well is going to connect. And the next item will be the lower section. So basically, in the K direction, we are saying that what will be the upper and the lower K, upper and the lower location of the K connectivity in my reservoir. For example, if you have let's say 12 layers in the K direction, So you are going to do the perforation or do the connectivity between the well and all these layers. So you need to start from the layer 1. It means that from the top layer to the layer 12. So from to the bottom. So you are going to connect your well to the K1 to K12. And also it will be the same for the injection. So you start from, for example, this layer and to bottom layer. And the next one is that next item is you need to tell the Eclipse that this well is going to be open or shut. In this case, we are saying that our production and injection well will be open. So write open. Or if your production or injection well, one of them are shut, you need to write shut here. And you have another items that you need to check for in the reference manual for the other items. But this 0.5 is a, for example, wellbore radius. So you are saying that for production well, my wellbore radius will be 0.5 feet, and for injection it will be 0.5 feet. Okay, so you have too many other things that you can specify in the that section, but the most important ones that you need to define is that well name, well location, and where will be the connectivity and the status of the well. Right now we define the well, we done the compilation. So well compilation is finished, and next thing is that we are going to tell the Eclipse that how we are going to inject and how we are going to produce fluid from our reservoir. Okay, for injection, let's go for jump for injection first. For the injection, you need to use well-con-inj keyword to control the injection wells, and the first item here is a well name. So you for the injection you have an injection well. So write it here. The second item that you need to have is that what you are going to inject. So in this case you are saying that I'm going to inject water. So write it here in the second item. And what will be the status of well? You are saying that my well will be open. So write it open. And how you are going to control your well? You are saying that I'm going to control based on rate. Okay, I'm going to inject based on the rate. So write it rate here, and at the end, what will be the rate of injection? It will be 50. Okay, so let's jump in the reference manual for a second to search for this keyword. I'm going to show you a different items that this keyword is taking. Okay, so here, as you can see here, this keyword is containing the data for the injection well, and it's going to finish with a slash here. And if you come here, you can see that fourth item for this keyword is a control mode. So you have a different control modes. For example, you can control your reservoir based on rate, or based on the reservoir volume rate target, or based on the bottom hole pressure or other things. Okay, so the important thing is here, if your control mode is rate, okay, so it means that you need to assign item number 5. Okay, so here for example, our control mode is rate, so we need to have some number here for fifth item number 5. And in this case we say, okay, we are going to inject 50. Okay, this is our injection rate. But if you change this to, for example, bottom hole pressure, it means that you need to identify item number 7. Okay, so it means that we have number 1, 2, 3, 4, 5. So we don't need to identify number 5. So number 5 should be default. Okay, Number 6 should be default as well, because we are not going to define anything there. Okay, but we need to define item number 7. It means that what will be the bottom hole pressure. For example, let's say we are going to say it's 200 psi will be our bottom hole pressure. So if you are controlling, for example, based on rate, so you need to tell the Eclipse what will be the rate at number 5. But for example, if you are going to to define based on bottom hole pressure, so it means that you need to tell the Eclipse what will be the bottom hole pressure in the item number 7. So if you write like this, you are going to get error. Okay, it means that you need to tell the Eclipse that I am going to have a default for these two, and then this will be, for example, 200 will be my bottom hole pressure. Okay, so just now, right, we are going to have control our injection well based on rate, and the rate will be 50. Now you need to we define the injection scenario. So we say that our injection will be performed based on this scenario. You need to do the exact same thing for the production well. Okay, so in the production well, let's bring this one here. For the production well, you need to use welcome prod keyword. So write welcome prod keyword here, and the first item will be the name of your well. You already defined the well spec section, so it should be exactly the same as this well. So production, and your well will be open, and you are saying that my control mode will be based on bottom hole pressure. So you have an exact same scenario here as well. So if you define, for example, control mode based on bottom hole pressure, you need to leave 5 items as a default, and then you need to define what will be the bottom hole pressure. So in this case, it's for example 2000. Okay, so let me show this one as well. So here in this keyword, so in the third item, you are saying that what will be the control mode. Okay, control mode for my production. If you choose, for example, ore rate based control mode based on ore rate, you need to define the fourth item. Okay, if you choose, for example, based on the water rate, you need to identify it in the fifth item. So in this case, we have bottom hole pressure. So Eclipse says that if your control mode is based on bottom hole pressure, you need to identify that pressure in item number 9. Okay, so we have item number 1, 2, 3. Okay, so we need to leave 5 items as a default, and we can specify bottom hole pressure in item number 9, which is 2000. And this is going to finish with a slash, and the whole keyword is going to finish with another slash. The next step is we already defined the well, we defined the compilation, and we define how we are going to inject or produce from our reservoir. The last step is that identify time steps. Okay, how long we are going to do the simulation, and what will be the time steps for our simulation. For example, let's go back to the presentation. So if you use t-step keyword, t-step keyword is saying that how many steps you are going to do the simulation. For example, 100 steps, and what will be the time steps. So in this case, we are saying that, for example, half an hour will be our time steps. So we are telling the Eclipse that to have a 100 time steps, and each time step should be half an hour. Okay, but you can change it. For example, if you want to do, for example, 500 time steps, and if each time step is going to be 1 hour, you can write like this. You can change your data file based on this, or you can define the dates, or you can use the dates keyword. The dates keyword, instead of having the time steps or defining time steps or number of time steps, you are saying that do the simulation and report the result in these times. Okay, so in this case, Eclipse is going to optimize the time steps, and it's going to report you the results in these the dates that you specified uh, for the Eclipse. So, and at the end of your data file, you need to have an end keyword. So it means that my data file is finished and I'm ready to do the simulation, to run the simulation. So if you write this end, it means that everything is done and I'm ready to run the simulation. So if I summarize, in the schedule section, you are defining the well, and you are doing the well compilation, and you are defining what will be the injection and production scenarios for my wells. So to define the well, you need to use well specs keyword. To do the compilation, you need to use comp that keyword. And for injection and production scenarios, for injection, you need to use welcome keyword, and for the production, you need to use wcomparat inject. And also at the end of your uh, data file, you need to specify what will be your time steps for the simulation, and your data file is going to finish with the end keyword.